Welcome to the second part of the lesson about graph. In this part of the lesson, we are going to explore ways of inputting an equation. Another function of graph is, in fact, the insert a new function, which allows one to do the following things. By clicking on the tab Insert a new function, a new window appears. As you can see, there are various common tabs which are relatively easy to follow. For the purpose of this lesson, we are looking at the very top drop-down menu defined as function type. For this lesson, we are choosing the standard function. The upcoming procedures will, however, also apply for the rest of the functions. In the function equation slot of this new window, one can write the equation to be plotted. In this case, I'm going to write a polynomial equation of order 3. More commonly known as a cubic equation. Please note that powers are written using the hat sign. After writing the equation, the next step is to specify the range of the graph in the From and To tabs, respectively. This tab's slot represents the number of coordinates to be plotted within the specified range. It is important to note that here, obviously, only integers greater than 0 will be accepted in this slot. The more the number in the step, the more accurate the graph. After having specified this information, we can also choose the preferences we have for the appearance of the graph, as we are doing right now, in fact. This we have seen in a previous slide. We are now going to arrange the graph to fit the screen as we have already done before. In fact, this procedure has been seen in part A of the lesson using the buttons zoom in, zoom out, etc. The illustration here is the end result, with values extending from x equals -5 to x equals 5. Please note that so far we do not know the corresponding values of y. The point of this lesson is to find the values of y for any given value of x, and there are 3 ways to do this. Method 1 would mean moving the mouse on a point in the graph, any point. You can note that simultaneously the coordinates at the bottom right corner of the page will change accordingly. This is, however, not such an accurate measurement. Let us now move on to the second method. The shown icon, evaluate or trace a selected function, is also used to compute the values of y for any given value of x. By clicking on the mentioned icon, a new window appears. This window, as you can see, is divided into 5 sections. The first step denotes the value of x, and this is in fact the only section whose value one can change. The value of y is here represented by f of x. For more calculations, one can find the differentiation or simply the gradient at a given value of x. This is represented by f prime of x. F double prime of x represents the second derivative test. This test is commonly used to determine the nature of turning points. And finally, let's move on to the snap to slot. In this drop-down menu, one can find 4 types of evaluation tools. The first evaluation tool, function, represents the graph in itself at any point. Intersection refers to points of intersection between two graphs. This would be in the case of having two graphs, obviously, which we don't have in the current example. Let us now move to the third option, which is x-axis. This leads you exactly where the graph cuts the x-axis. Choosing the last option, extremum, one will find the coordinates of the turning points, as we are showing you right now. On finding the extremum, the program automatically gives you the values of x and y in the respective slots. And finally, we shall discuss the last and third method. There is another icon on the taskbar that helps you compute the value of y for any given value of x. Clicking on the icon shows an evaluation table. The following window opens. Again, in the From and To tabs, one can specify the range of the graph. The interval can be specified in the gap as shown by the arrow. Obviously, the smaller the interval, the more calculations you will have. And on pressing the calculation button, all the fields will be calculated automatically. The columns in this table are the same as in the second method: x, f of x, f prime of x, and f double prime of x. Let us now move on to some further practice. A vehicle starts from rest and its velocity is measured every second for 16 seconds, with values as appearing in the table on the right-hand side of the screen. The following are the questions you will have to solve. 1. By using the graph program, plot the velocity on the vertical axis against time on the horizontal axis. 2. Opt for simple black in the presentation of your graph, ensuring that only the coordinates are marked. Edit your graph accordingly so as to have it clearly occupying your screen. 3. Find the best trend line that fits such data and the corresponding r-squared value of the chosen life. Keep only this trend line visible on your screen. 4. Using any of the three methods illustrated in this presentation, find the time value which corresponds to a velocity of 10 meters per second. Using any of the three methods illustrated once again, find the velocity value corresponding to a time of 5.5 seconds. 6. On the same axis, draw the graph of y equals x squared minus 4x, using a red color to represent your data. And finally, evaluate the point of intersection of the two graphs.